Welcome to Winter WonderLearn. My name is Yara Mahmoud and I'm an Engineering Outreach Program Instructor here at Ontario Tech University. Today we're going to be building our own Snowball launcher. But first of all, we're going to learn about a few things that are going to help us with building our Snowball launcher. Before we get started, we're going to go over a land acknowledgement. We are thankful to be welcome on these lands in friendship. The lands we are situated on are covered by the Williams Treaties and are the traditional territory of the Mississaugas, a branch of the Greater Anishinaabe Nation, including Algonquin, Ojibwe, Odawa, and Potawatomi. These lands remain home to many Indigenous nations and peoples. We acknowledge this land out of respect for the Indigenous nations who have cared for Turtle Island, also called North America, from before the arrival of settler peoples until this day. Most importantly, we acknowledge that the history of these lands has been tainted by poor treatment and a lack of friendship with the First Nations who call them home. This history is something we are all affected by because we are all treaty people in Canada. We all have a shared history to reflect on, and each of us is affected by this history in different ways. Our past defines our present, but if we move forward as friends and allies, then it does not have to define our future. So today our lesson is going to be focused a bit around something called STEM. So you may have heard of STEM before. STEM stands for science, technology, engineering, and math. So science is understanding the world around us. Technology is the application of scientific knowledge for practical purposes. Engineering is solving real-world problems using the other aspects of STEM, which are science, technology, and math. And math, well, we all know what math is. It's the science of numbers and operations. But today we want to learn a bit more about engineering. So what do engineers do? They invent, design, build, test, and analyze machines, systems, and structures to solve all different types of problems that we face in the world around us. So there are so many different types of engineers that you may have heard of, like mechanical engineers, civil engineers, software engineers. There are so many types. But a main one that pertains to our lesson today is aerospace engineering. So aerospace engineering involves designing aircrafts, building spacecrafts, and developing propulsion systems. And these engineers, they deal with anything that flies. So that could include satellites, planes, rocket ships, even missiles. So our main question today is, what is flight? So flight is the action of moving through the air. It occurs if a structure or living thing takes advantages of the properties of air. So there are so many things around us that fly, things that we have built, and things that are found in nature. For example, planes, helicopters, birds, butterflies, bees. There are a lot of different things that fly. And they all do this using the properties of air. So what are the properties of air? So air has many different types of properties. Some main ones are that it has mass. It takes up space. It has pressure. It expands when heated. It's compressible, and it's an insulator. So you may be thinking, how are some of these things true? Like, for example, how does air take up space? So let's think for a second. If you had something like a plastic bag and you were waving it through the air, the plastic bag would get filled up and it would almost take the shape of the air as if it was being filled with something. And that's because it is. The air is taking up the space in the bag and it's filling it up. So in flight, we need to take advantage of these properties. For example, air takes up space. So to fly, we need to cut through the air. So things that help us take advantage of these properties are called forces. So a force is a push or pull that influences the motion of an object. So there are a lot of different types of forces that you may have heard about. There's things like elastic force, friction, electromagnetism. So force, all these different types of forces, they enable motion, which is the movement of an object from one place to another. Flight is a type of motion. So let's learn a bit more about the forces that act on flying vehicles. So there are four main forces that act on flying vehicle. They're thrust, drag, lift, and weight. So let's start with thrust. Thrust is a force that acts on a moving object, such as an airplane, and it acts in the direction of motion. It's created with things like a propeller, a jet engine, or a rocket. So air is pulled in and then pushed out in the opposite direction to cause the thing to go forward. So it's a forward force. So a good example of this would be something like a household fan. So it pulls air in from one side and pushes it out to the other side. So the opposite force to this is drag. So drag acts opposite of the direction of motion. It tends to try and slow down an object. So drag is caused by friction, which is another type of force, and differences in air pressure. An example is, for example, like when you put your hand outside the window of a moving car. You feel your hand start to get pulled back, and that's from drag. Next is weight. So as you can see in the picture, weight is a downwards force, and weight is basically the force of gravity that's pulling the vehicle down, and we try and combat that because we want our flying vehicle to stay in the air and not be pulled down. So the force that helps us do that is lift. It's the force that resists weight, and it holds the airplane in the air. So a lot of the lift is caused by wings, or the wings of the airplane. They create most of the lift that's used in the plane. And as you can see, lift is always 90 degrees to the direction of motion. So it's like a right angle. And all these forces work together to help our flying vehicles fly. So now that we've gone over some things that are going to help us build our snowball launcher by learning more about flight and forces and properties of air, we're going to get started with our activity. So here are some materials that you're going to need for today. And don't worry if you don't have all of them, there's always alternate materials you can use. So some useful things are going to be tape or hot glue or anything you can use to stick things together. And a toilet paper roll, rubber bands, perhaps you'll need a balloon, some pencils, a cotton ball, popsicle sticks, and any type of recyclables, so things from your recycling bin. And using these materials, we can make a whole lot of different snowball launchers. So within our activity, we're going to go through it step by step using something called the engineering design process. So let's take a closer look at the engineering design process. It has 5 steps. The first step of the engineering design process is always to identify the problem, because in order to create a solution, we must know what our problem is, or what it is that we're trying to solve. The next step is to brainstorm ideas. So when we're brainstorming ideas, we write everything that we can think of down. And during brainstorming, no idea is a bad idea, because even the craziest ideas can be turned into something amazing. And then our next step is designing a solution. So in this step, we pick our best idea, or we pick a combination of ideas. And using those ideas, we try and think of a solution to our problem, something that'll solve the initial problem that we identified. After that, we make a model. So that could be like making a physical model, or maybe you're making it on something like a computer. But during this step, this is really useful because we can visually see our solution to think whether it'll work or not. And that brings us to our last and maybe our most important step. So this is where we test and evaluate. So we use the model that we make and we try and test it and see whether it'll work or not. And then we evaluate. We think what went well, what didn't go well, what can we improve in our model, what do we want to stay the same, and we do this so that we can get the best result possible. And if we find something in our model that we think, maybe there's something I can improve here, we can always go back to one of our previous steps. Maybe you want to go back and brainstorm some new ideas. And that's so, in the end, we can guarantee that we end up with the best solution possible. So let's get into our activity. Let's start with identifying our problem. So, our activity is that you're having a friendly snowball fight with your friends, divided into two teams, but throwing snowballs the old-fashioned way is quickly turning out to be inefficient. Your arms are starting to hurt, you can't throw them as far. So we wanted to design a solution. So our problem here is that throwing snowballs isn't working, and we want to try and solve that or find an alternate way. So let's build a snowball launcher using our knowledge of forces and aerodynamics to do the work for us so that we don't get as tired. So we want to start with brainstorming. And if you want, you can take a moment here to pause the video and you can jot down some ideas that you may have using some of the prompt questions that we have on screen. So some of those are, what kind of launcher do I want to create? Maybe a trigger launcher, or something like a slingshot or a catapult. What materials will I use? So this is a good time to see what materials you can find. Maybe any recyclables you found, elastic bands, balloons, and you can use those to try and find the best possible snowball launcher for you. How can you maximize the range of your launcher? So you want to try and make it go as far as possible. How can you increase thrust and lift? So you can try and combat the weight and drag that's pulling your snowball back and down. How can you reduce drag and overcome weight? And what projectiles will I test out? So maybe what will you try launching? Whether that be like a little cotton ball or maybe a piece of crumpled paper. You want to test out different ones. So now we're going to take a bit of time and design a solution. And during this step, you want to sketch a possible design, maybe using a piece of paper. So I'm going to take a moment here and I'm going to sketch my possible design. As we draw, our designs may not be perfect, and that's totally okay. So an important thing that we can try and do is label our designs. Labeling our designs helps us depict exactly what's going on in the design, and it helps other people understand what's going on in our design as well. And you can take as much time as you want to draw out your design or try and brainstorm new ideas until you find the design that is perfect for you. Hopefully now you've each had enough time to design your own solution. Here's mine, for example. It's a slingshot snowball launcher. Each of you may have ended up with completely different designs, and that's totally okay. If you're feeling a bit stuck, there are some ideas up on the screen. For example, slingshot snowball launchers, catapult snowball launchers, and much more. Now that we've each designed our solution, we want to move on to our next step, which is making a model. This is the next step in the engineering design process. So we're going to try and build a prototype of the design that we sketched. Remember to consider the forces acting on flying vehicles that we learned about earlier. So some things to remember are that in order to overcome gravity that pushes us down, we need to create lift to push us up. And in order to maximize lift and reduce drag, which pushes us back, we need to increase thrust, which pushes us forward. We can do this in a variety of ways. For example, using something stretchy, like an elastic band, or using something such as a catapult that's going to throw your snowball forward. So take a moment now to make a model of your design. Hopefully now all of you have had a bit of time to create the model of the design you came up with. Here's my model, for example. It has an outer piece that holds the slingshot, and then it has an inner piece which is going to be stretched back and pushed forward, so it shoots our snowball forward. And that brings us to our next step. So after we've built our model, we want to test and evaluate to see what's going to work in our model, what's not going to work, and if there's anything we should change. So to test my model, I'm going to use a little piece of crumpled up paper to simulate a snowball. You can use anything that you see fit. Maybe if you have a small ball, or if you have a cotton ball, any of those things would work. So I'm going to put my snowball inside my launcher. I'm going to pull it back. Oh, and there we go. It has shot forward. So if I want to test it out, I can also test it out using different materials. As I mentioned, perhaps a ball or a cotton ball to see how it works using different things that are different weights. So after I've tested my model, now I want to evaluate. So evaluating is a really important step in the engineering design process because in engineering, we're always trying to improve what we build so we can get the best outcome possible. So I want to see what worked in my design. So was my design successful in overcoming drag and weight? Did it have enough thrust and lift? So I will say, yes, my design did have a lot of thrust and lift. One thing I would improve, perhaps, is to give it more lift. So my snowball, it went really far, but it didn't go really high unless I were to aim it otherwise. So maybe that's one thing I can improve in my design. Another thing perhaps I'd like to improve in my design is to make it aim better. So my slingshot, when I shoot it, it goes forward, but sometimes it'll go off to the side a bit. So maybe that's one thing I'd like to improve. So as I said, in engineering, we're always trying to improve our designs. So you want to find things that you can improve, and you also want to find things that work so you can keep those ideas in your design. And if you'd like, if your design didn't work, you can always go back to the brainstorm step and create a new design. Thank you all for joining us today here at Winter Wonderland. I hope you guys had a good time and that you learned something new. And I hope to see you guys all next year. Bye for now.